Now let's look at an example where what we want to do is construct a truth table for P and Q if and only if Q implies the negation of P. This one's going to take a little bit. So, what we're going to do here is, since we just have two statements, means you don't have to worry about making too many rows at least. We're going to have a lot of columns. Start with our standard pieces, P and Q. And bear in mind that this is going to be a lot of T's and F's. So we're going to be very careful and go through this slowly. So, make our standard setup for two pieces. Then, we have to talk about the conjunction in that first piece that we have. So, we're looking at P and Q. Remember, in order for a conjunction to be true, both pieces have to be true. So, it happens here, and thankfully, not much of anywhere else, because that's going to make our life a lot easier going down the line. Next, what we're going to do is start looking at our negated pieces. So we're going to look at the negation of P. And then after this, we're going to turn that into the conditional so we can get that other side. So if we're negating P, that means we're just flipping over all of these values. So we get false, false, true, and true. Be very careful going through this to be sure that we're connecting the right pieces here, because it's easy to lose track of this stuff and start jumping into the wrong rows and go all over the place and completely throw the whole thing off. But here, we're just flipping these guys. Then, we're looking at whether or not Q implies the negation of P. Well, that means we're going from here to there using something like those conditional arguments that we saw in the previous example, where we've got true and then false. That's the big case we have for conditionals. This is false. Here, false, false. Trivially true. True, true. Definitely true. False, true. Trivially true. Okay, now we have all of our pieces, and it's time to put them together into this guy right here, where I don't think I have quite enough space to draw it clearly, but we'll get what we can, because we're looking at the bidirectional, the biconditional that is, between P and Q, and if Q, then not P. Where what we need is for our truth values to match up. But we've got true and false, false and true, false and true, false and true. None of them match, which means this is always false. And that's an example of something that we're not going to see too often here, but this is a thing called a self-contradiction. Where a self-contradiction is a statement that is never true. So we saw the idea of a tautology, which is a statement that is never false. Here we have essentially its opposite, a statement that can't be true. And now that we've gone through all this stuff, let's just take a quick recap on all of our pieces, because we've got 5 of them and it's easy to lose track of each. So, for negations, that's saying something like not, and since we have the opposite meaning, it has the opposite truth value. For conjunctions, you can see that as being something like and, where conjunctions are only true if both components are true. Then you have disjunctions, which act like or, and disjunctions are only true when both statements, they're only false when both statements are false. Then we look at conditionals, which are the if-then statements. Conditionals are false if the antecedent is true and the subsequent is false. That is, the first part's true and the second's false. And then finally we have biconditionals, the if and only if statements, the equivalent statements, where these are only true when the pieces, the components, both match.